All right, we are given the arctan x, that is the tan inverse of x, as y. So we are to show that the derivative of this is 1 on 1 plus x squared. All right, now let's understand something. Now when we have y equals to cos x, okay, my x will be cos inverse of y. So if we want to find y is not 1 on cos x, no. All right, so this is the inverse form of it. All right, now we are given y equals to tan inverse of inverse of x. Okay, so don't forget that x is the same as tan y. Okay, because y is the same as tan inverse of x, as simple as that. Okay, so let's take the derivative of this. Now from here it will be the x dy. Okay, differentiating x with respect to y, so the derivative of tan will be sec squared, so that will be sec squared y. All right, now let's recall this identity. Now when we have cos squared theta, okay, let me use y since we are dealing with y. Cos squared y plus sine squared y is the same as 1. Now let's divide through by cos squared y because we have sec here. Now over cos squared y, cos squared y, cos squared y. So this one will cancel. 1 plus, now sine over cos is tan. Okay, so this side will be tan squared y. Now when we have 1 over cos is sec, so it will be sec squared y. Okay, now we have the sec squared y here in place of this, but don't forget that dy dx will be 1 over, okay, sec squared y. So this one has been changed, so this one too has changed. So dy dx, I'll do substitution. 1 plus tan squared y. So dy dx, so we have 1 on, so sec squared y is 1 plus tan squared y plus tan squared y. Now let's go again, dy dx. Now let's look at the proof. We have 1 on 1 plus x squared, and let's check. We have 1 on 1 plus tan squared y. So let's go again, 1 on 1 plus, so we can write this one as tan y or squared. It means sine squared x is the same as sine x or squared. Okay, now look, this is tan y, this x, so in place of tan y I'll put x there. So this side will be 1 on 1 plus, this is tan y, that is x, so x squared. Therefore, divide x 1 on 1 plus x squared. Simple as that. Okay. All right. So that's that. So that's the proof.